last part of actually this unit too. We're going to have a chapter, like a test on this next Tuesday. Okay, we're going to talk about graphs today. We're going to look at a graph and we're going to answer a bunch of questions. Now, we're going to do two different types though. We're going to do graphs of F, which is easy because that's what you're used to. And then we're going to do graphs of F prime, which you're not used to, which are harder to do because you have to totally change your mind to think, okay, it's not F anymore, it's F prime. All right, so let's go ahead and do a graph of F of X. Okay, these come from like ham and stuff, like RAM. These are basics. All right, so let's say that we have this graph. Here's -2. Here's +2. And let's say we have a dot here and a dot here and one in the middle. And then our graph is just a nice, beautiful polynomial. Looks just like that. Okay? Nice, huh? It's like a nice little cubic function there. And then I'm going to ask you some things. And I'm going to give you a little chart to fill in too. Okay? So the chart will look like this. We have... I think I need to go farther. 1, 2, 3. Yes. Okay. So this is going to be 0 plus minus. Okay, it's going to be a sign chart. And the derivative and the second derivative. Okay, so I'll let you copy that down real quick. So I'll have something like this on the quiz for the graph of F. This is just the graph of y equals f of x. This is the stuff that you're used to. You've seen these growing up your whole life, probably. All right, so when you look at this graph, you can tell me where f prime is 0. Okay? You can. You know that. Where is f prime 0? Perfect. Here and there, right? F prime is 0 because... Yes, the slope of the tangent is 0. At maximum and minimums, that's where f prime is 0. So at plus and minus 2. Okay. Now, where is the derivative positive? The derivative is positive on intervals of increasing. Right? That's where the slopes of all of my tangents would be positive slopes. So there and also over here. So where's the derivative positive? That would be from -infinity to -2, and then from 2 to infinity. You want to use brackets? Go ahead. Where is the first derivative? Negative. That would be where your graph is decreasing. So that would be, -2 to 2. Okay, not so bad, right? These are pretty good. Okay, now where is the second derivative equal to 0? The second derivative is equal to 0 at inflection points. Do you see where this goes from? It's going to be right in the middle of the two, the maximum and the min. Okay, so at the point 0, 0, you could just say when x equals 0. And where is the second derivative positive? That would be, I ran out of colors. I'll go back to black. It's positive when you are concave up. Concave up. Yes, 0 to infinity.
Can you quickly define what inflection point is again?
Yes, in just a second. And then finally, when is it concave down? Right here, concave down from -infinity to 0. Okay? So yeah, let's go ahead and remember what all these things are. Bless you. When you're looking at the graph of f, okay, f prime is equal to 0 at all of the maximum and minimums. It's where the slope of the tangent is 0. Slope is 0, okay? F double prime is 0 at an inflection point. Inflection points are going to be where your graph turns from concave up to concave down or vice versa, where it changes. It's always in between the maximum and minimum, right in the middle of them. Oh, yeah. Yeah. All right, so we're feeling pretty good. There's going to be one like this on the quiz. You'll whiz right through it. It'll be nice. Now let's go to the second one, part B. Now we're going to look at the graph of f prime of x. Okay. Drugs already? Who was that? No? Do you think Peyton's watching this? Or ever? No. Okay. All right. Let's not do that, right, Trevor? Trevor watched it. No, not at all. Okay, so here we go. Yeah, I would feel a little bit bad. Probably not. All right, so go like this. 1, 2, 3, 4. 0, 1, 2, 3, 4. And then let's draw a polynomial that goes like this. Oops, I kind of missed on that last part. There we go. Okay. Now, this is the graph of the derivative of the function, and they're going to ask you questions about the original function.
The original?
Yes. Where is f of x increasing, decreasing, okay? And then it's going to ask you, where does f of x have any extreme values? And what are they? 1, 2, 3. Okay? All right. So you physics people, this is the velocity graph, is that right? The graph of velocity? No, it's not the position graph. The velocity, yeah. Okay. I don't look at it that way because I'm not a physics person. So this is what I'm going to do. I know that f of x is increasing whenever my derivative is positive, right? So it's increasing whenever f prime is greater than 0. That's where my original graph is increasing. Now you have to think of this as the x-axis, and this is the f prime of x-axis. Okay? So whenever my f prime of x is positive, that's where my original graph is increasing. So where is f prime of x positive?
-4.
Yes, exactly. It's positive there.
0 to 4.
Perfect. And it's positive there. That's where my original graph is increasing. From negative infinity to -4, and then from 0 to 4. Okay? When it's above the x-axis, the derivative is above the x-axis, that means that the slopes are positive of your original graph, which means it's increasing. Okay, where is this thing decreasing then? It's decreasing whenever f prime is below the x-axis, whenever f prime of x is negative. That would be down here. So from -4 to 0, and then over here also 4 to infinity. Any questions on that? Is that hard to you? It was always hard to me because I had to switch. Like you look at this, you're like, no, the graph is decreasing here. No, it's not. It's the derivative graph now. Where are the extreme values located? They're located whenever f prime of x equals what? 0. So where are the zeros of f prime of x? Yes, they are on the x-axis. They are not this point, the maximum and minimum of this graph. That's not it.
Do you just want the x values, or do you want it?
I'm going to need, no, just the x values. Yeah, you can't tell the coordinates unless I give you more points or something. So they occur at dang it. They occur at -4, 0. That's okay. And +4. Now we can also tell. You have to tell me what they are, though. What kind of extreme values these are. Are they maximums or minimums? And you can tell that. So let me show you how to tell that.
Increasing to decreasing.
Yes. So this right here is,
That's a maximum.
that one is, what's it doing? Increasing there? It's increasing on the left, and it's decreasing on the right.
And you know that because I positive negative?
Yes, because of this right here. We just said it. It's increasing on the left and decreasing on the right. So what kind of a point increases on the left and decreases on the right? A maximum. So -4 is a maximum.
I always have to sketch it out.
Oh, I do too. I do too. It's hard. I have to like really think. Okay, let's look at x is 0. X is 0 is decreasing on the left and increasing on the right. So that would be a minimum.
Do you have to graph it then?
No. Mm-mm. And then the last one is increasing on the left and decreasing on the right. That would be a maximum again. Okay?
Is this what was supposed to be hard?
Yeah. It's not? Okay. Good. Maybe I'm getting better at doing it myself. Yeah, that's true. There are a lot of physics people in here. What happened? Jack, what's he doing? Oh, he's not doing this? No. All right, number 3. I never labeled any of these. Okay, so let's go ahead and let's do one last one. Let's do one more of the graph of f prime, but this one's a little bit different, okay? Those of those ended up being they're polynomials. They're originally polynomials. Okay, so go ahead and graph this with me. Graph this as best you can. I'll try and tell you some points on there. Okay, go ahead and go 1, 2, 3, 4, and 1, 2, 3, 4. All right, let's put a point way up here at -4 something. Doesn't matter. At -2, put a dot on the x-axis. At 1, put a dot on the x-axis. At 2.5, put a dot down here. Sorry, it's 2.5. And then at 4, put a dot right there. All right. So this graph is going to be a little bit different. It's going to go like this. It's going to touch the x-axis here. And then it's going to go up and through, and then down to here to there. Okay. It's a little bit different. So go ahead and sketch that real quickly. Okay. Here we go. So here's the graph of y equals f prime of x on the interval from -4 to 4. Yeah.
Can f prime graph ever have like a flat? So like you know the 2, like -2 to 1. Can it have just like
Yes.
flat
Yes. That means there was like a horizontal line because the slope is 0.
Okay.
Yeah. We did those. We did like segments of that. Remember, like if you had a graph that was all lines put together, then the derivative was line segments that were flat-lined because they're all, yeah. Okay, so here we go. We're going to say where is f of x increasing. Okay, let's just start with where is f of x increasing.
And it's on that interval?
From -4 to 4. Okay, so sometimes it's nice if you label this as x and this is f prime of x. So you're really asking where is f of x increasing? That would be where f prime of x is positive. Now be careful, 0 is not positive, okay? So it's actually increasing from -4. You can include -4, that's fine, to -2, and then from -2 to 1. If you want to, you can put brackets on those, but not on -2 for sure. You could have parentheses on those, I don't care. But don't put a bracket on -2 because it's actually not increasing at -2. Because right there, f prime is equal to 0. We're going to talk about that.
If we didn't put a bracket at -4?
I wouldn't mark you wrong. No. Okay? All right. Where's this graph? Where's f of x? Not this graph, but where's f of x decreasing? Okay, that's a pretty straightforward one. That would be from 1 to 4. 1 to 4. Okay. The next one would be, we haven't done this yet, but where is f of x concave up? Concave up. Okay, it's going to be concave up when f prime of x is increasing. Not when it's positive, that's different. But when f prime of x is increasing, that's when it's concave up. Okay? So for this graph, I am, yes, from -2 to 0. And then also from 3, or it looks like 2.5 to 4. It's gross, huh? Sorry. But this is the one from the book. That's what they had it as. Okay? That's where it's concave up, where f prime is increasing. Now the next question is going to be a little tricky. At which x coordinates does f of x have any maximum or minimum? So they'll say local extrema, max or mins.
Which is -2, 1, and 4.
Not quite. Not quite.
But didn't you say like endpoints of graphs are?
Yes. So we gotta look at the endpoints. So the endpoints are going to be there. So x equals -4. Now, you would think that at -2, that would be a max or min, but it's not. And you know why? Because the function is increasing on the left, and it's increasing on the right. So a graph that's still increasing on both sides is not a maximum or a minimum.
1 is.
Yes, 1 is, and then so is 4. Okay, it's so easy to just say f prime of 0 are all the maximum minimums, but it's not in this case. Can I show you an example? Like you're probably thinking, well, when does that happen? If you have something like this, let's say this is the graph of f of x, and my graph is increasing, and I do this. Remember that? We've had this, a cubic function. My graph is increasing. Right here, f prime of x equals 0, and then my graph still increases from there. Is this point a maximum or a minimum on the graph? No, it's not. Your graph is increasing on the left. It's still increasing on the right. It is not a maximum or minimum. Okay? That's probably what's happening there. All right, so -4, though, what would -4 be? Is -4 a max or a min?
Minimum.
It's a minimum. Okay, so let's say here's -4. Here's x equals -4 on our f of x. What's it doing next to -4? It's increasing. So if something is increasing next to it, it's a minimum. I know you look at it and you think maximum. It's up there, right? It's high. But no, it's increasing on the right side of it. Okay? Gross, right? Nothing's happening on the other side. Yeah, it's an endpoint. So, yeah. Yeah, because nothing's happening on the left side of it. The graph is only from -4 to 4. So you can't see what's happening on the left. It's here, but on the right, we know it's increasing because f prime of x is positive. So it's going up from there.
So
Yeah.
it doesn't matter about the graph, it matters on the wording.
Yep, exactly. Yeah, I know it's so easy to just look at the graph and go, oh, that's a maximum, but it's not. Okay, what about 1? It does. It lies to you. That's what makes it so hard. The graph is positive here, negative here for x equals 1. Yes, so something that is positive on the left and negative on the right, so increasing on the left, decreasing on the right would be a maximum. Now be careful with the last one. How's what?
How is that one a maximum? The last one.
The last one?
Yeah.
It's increasing on the left.
4.
4. What's happening to the left?
No.
Oh, 4. I haven't gotten to that one yet. I haven't said that one yet.
Yeah, but I just didn't.
Oh, okay. So let's look at 4. X equals 4. This is where our graph is ending. Nothing is happening on the right side of 4. What is happening on the left side of 4? it's decreasing. It's coming down to it. So that would be a minimum. It's weird. They're both minimums, even though one is way up here. You're agreeing. Yeah, you got this? That's good. Oh, you're telling Kat that you hate this stuff too? Yeah. Oh, okay. It's confusing. I know. But yeah, we could do concave down. Yeah, let's do that then. Okay, but do I need to re-talk about all of these right now? Yeah? Okay, so you have -4, 0, and 4. Okay? So let's say this is -4 on our graph. I don't know where it's at. I don't care. Nothing's happening on the left of it, but I know that my function is increasing on the right. So if I have something that increases on the right, then that means that this is a minimum. Okay? Yeah? And then what about 0? Let's look at 0. What's happening on the left side of 0 is that our graph is increasing because it's positive, and then it's decreasing on the other side. Positive, negative. So that would mean it's a maximum. And then if you look at 4, give yourself a point for 4, nothing's happening on the right. Don't draw anything on the right side. But on the left, we know that from our graph, f prime. Oh, you're right. Yeah, thank you. 1, thank you, yeah. On the left side, it is decreasing, right? So it's decreasing means it's coming down to 4. So 4 would have to be a minimum. Okay. Yeah, let's do concave down. Concave down is going to be when f prime of x decreases. Okay, so where is this thing decreasing? It's decreasing from -4 to -2, and then it's, yeah, and then it's decreasing from 0 to 2.5. So concave down would be -4 to -2, and then 0 to 0? Yeah, to 2.5. Okay, last question. What are the x coordinates of the inflection points of f? Inflection points. Okay. Inflection points are going to be when f prime of x equals 0. F prime of x equals 0. So where does this thing equal 0? -2, 1, and 4. Wait, that's not right. No.
You told us in the lesson that the inflection points are max f prime when equals 0. Or was
Yeah.
that
I did.
Yeah, yesterday's lesson, that's all we wrote down. You put f prime equals 0.
No, f double prime. No, inflection points are where f double prime equals 0, and that's going to be where f prime has a maximum or a minimum. There we go.
Oh, I see. Wait, so then
Yeah.
f prime
Okay.
is what?
So then that would be the maximum and minimums of the f prime graph. Yeah, that makes sense. I wrote it down. I'm like, that doesn't make any sense. No. Okay. So -2, 0, and 2.5. So
what about the endpoints? Those are maximums.
yeah, they don't say anything about that. They just want, because endpoints aren't going to be inflection points. Because inflection points means it's changing from something to something else. There's nothing on that side, so it can't change.
Wait, so
Yeah. Okay. So the inflection points, that's okay. The inflection points are going to be when f prime has the maximum minimums. Okay? The ends, no, because inflection points mean it's changing from concave up to concave down. There's nothing happening on the outsides of the endpoints. So just the graph, just the inside points will be inflection points.
It's not hard, it's just a lot to
It is a lot to remember, and then the fact that I messed you guys up on the last part, that's
I
stunk.
have so many things written down, like little footnotes. A lot of this.
Oh, what did I do?